Hi everyone, my name is Kartik and my channel is about mental models. I hope you're liking my videos. If you are, then please subscribe to my channel, and as always, please like and share this video with everyone you know. In this video, I'm going to be talking about the sampling mental model. Sampling is, of course, a mathematical technique, but there are some learnings we can use in the world of mental models to help us get to better and or more positive outcomes. So how do we define sampling? Well, it is about how much of the total population of something we are looking at. That's what a sample, in effect, is. Now, this might seem quite obvious, but it's a good, simple definition, and I don't want to overcomplicate. Why do we sample, or what is the need to sample, is just as important to understand. Again, it may seem obvious, but it's because it would be impractical to look at the total population from a cost or even operational standpoint. And in some cases, it may actually be impossible, such as if we were to look at the entire population of, say, China or India, it would be near enough impossible to get a response from everyone. And so the idea behind sampling is that there will always be, or there are always and always will be, constraints such as time constraints and budget constraints. Therefore, people will try to draw a conclusion or get to a result of particular significance from the smallest sample. And then that sort of helps with the cost and the operational aspect and the time or the budget aspect. So there are a few factors when we determine a sample. There is the population size. So these are factors. There is the population size. The larger the population, the greater the sample size required. Number two, second, is the population proportion. Population proportion. This affects the sample. If we have 20 things which are uniform, so let's take an example of fruit. Let's say we have 20 apples, and we select a sample of 6 apples to give us assurance over what it is we are testing, because we think 6 is the right number. So if there are 20 apples, our sample size is 6. But if the 20 pieces of fruit are made up of 5 pears and 15 apples, then even though this adds up to 20, we wouldn't ideally seek to choose sort of 3 pears and 3 apples, because that would give us our 6. We wouldn't seek to do that, because sampling 3 out of 15 apples might be too low of a sample for the apples proportion. So it might be better to do a sample of 1 pear and 5 apples, which gives you your 6, or even a sample of 2 pears and 4 apples, which again gives you a total of 6. So we're testing the same sample size, or we're getting to the same sample size, but our population proportion, or our sample proportion, is different. Our population proportion is different, and therefore our sample proportion will be affected. It will be different, but not necessarily larger. Next is margin of error or precision. This is about how closely representative we want to ensure our sample is to the population. Do we want it to be 80% precise, or 95% precise, or even 99% precise? When you're sampling, you can't ever achieve 100% precision. This is always going to be a trade-off. And so we want to make sure our sample is more representative of the population, and therefore the results the sample gives are more precise. Essentially, the closer we are in terms of precision, the more accurate our results are going to be. If we want a higher level of precision, we may need to select a bigger sample or even change the proportions like over here. So fourthly is variability. If a population has a greater variability, then this will affect the outcome. And to compensate for this greater variability, again, a bigger sample would be required. The greater the variability, the greater the sample size required. If there's a little bit of variability, then you can select a relatively smaller sample size. If there's a lot of variability, and so to cover that, we would need to select an even bigger sample. And finally is the confidence level. This is the likelihood that the results obtained from the sample are within the associated precision. So point number 3. Let's say we have already set a precision of 95%. So let me get another colour. So down here we've got this. So we've set a precision of 95%. That means that we are willing to accept a margin of error of 5%. I'm going to call that MOE, margin of error. But how confident are we that the margin of error is limited to this 5%? This is what the confidence level is. Do we want to be 80% confident that our margin of error is only 5%? Or do we want to be 90% confident, or even 95% confident that our margin of error is not larger than 5%? As your required confidence level increases, your sample size will also need to increase. Sounds a bit obvious. A confidence level of 99% will require a larger sample than a confidence level of 80%. Again, sounds obvious, and these are not sort of earth-shattering factors, but when we're thinking about samples, this is how we break it down. Now, I've gone into a bit of technical detail here, but don't worry if you didn't understand this on the first go. Feel free to rewind and watch this part of the video again. I'm sure it will all make sense. From a mental model perspective, we are more interested in outcomes and the accuracy of the final result, because the greater the accuracy of results from sampling, the more likely we will have a positive or better outcome, because we will be able to base our decisions on more accurate results. So being mindful of this need for accuracy, the following 4 factors have these effects on the accuracy of the results. So these are the 4 factors: population size, sample size, confidence level, and margin of error. And so if we increase the value, so if the value is increased for the population size, what would happen to the accuracy if all other things remain the same? Well, if we increase the population size, the accuracy would decrease. So if we kept the sample size the same, if we haven't changed anything else, an increase in population size will reduce the accuracy, will give us a lower accuracy. Similarly, if the population size shrinks or the value is decreased, then if everything else stays the same, our accuracy, the accuracy of our result, will increase. Secondly, the sample size. If we increase the number of samples we're testing, our accuracy will increase. Similarly, if we reduce or decrease the sample size, our accuracy will decrease. Confidence level. If we want a high confidence level, that we want to be in a certain margin of error. If we increase that confidence level, that is, then our accuracy will also increase. But if we are willing to be less confident, then of course, if our value is decreased on the confidence level, we're willing to be less confident, then our accuracy will also decrease. And finally, margin of error. If we are willing to increase the margin of error, so from 5% we're willing to accept 10 or 20% margin of error, that means the quality of our results, the accuracy of our results will reduce. But if we want to make our margin of error smaller, decrease the value, so from 5% we want to make it only 1% margin of error, then again our accuracy will increase. Taking this further, when we are involved in a certain scenario and have certain information to help make a decision or move forward in a certain direction, to get us to a good or better outcome, we need to quickly work out in our mind whether or not the information is reliable, and in most cases, how reliable it is. So these factors. The information you have will in some way be a sample or a subset of the population, and this is why sampling is quite an important mental model. And so the biggest mistake we can make is drawing conclusions from too small a sample size. The second biggest mistake we can do is knowing that the sample size is too small and not even thinking to explore increasing this or changing proportions to make it more reliable. Now, using this mental model is not about questioning the validity or accuracy of a sample all the time, but it is about two things. Number one, exploring what isn't obvious. And number two, knowing how easy it is to corrupt our samples with bias. Now, I have left you with a number of messages and takeaways throughout this video, and there is a lot to think about and absorb. So one final thing, and I will end it here, is that the next time you hear a statistic or are provided with some form of information, think about the sample size, and always remember that the larger the sample, the closer you will always be to the truth. If a sample is very small compared to the population, then think twice if you want to take it seriously and rely on that piece of information. And on that bold statement, that is all for this video. I hope you liked this video. If you did, then please check out my other videos flashing on screen now. I'm sure you'll like them too. And I will see you in the next video with another mental model. Thank you for watching. Bye bye.